Alright, so for this pseudocode algorithm, our flowchart will look something like this. A couple of things I noticed students messing up. We're very good at identifying for example, the if and during the actual loop, because the template for the for loop is very similar. Some people are misdefining, for example, Euler, they just run an E. Remember that you're running it essentially to a computer, right? You can't introduce variables that haven't been introduced. Just make sure you write Euler's in the whole term as well. And just don't forget that if you're inputting data or if you are actively outputting data, then you're using the rhombus shape instead of the rectangle. Lovely, okay. With our desk check, it should look like this, remembering that your initial value of Euler is 1 because you've defined it as 1 in the question, or rather in your flowchart. So you'll have 1 plus 1 over 1 equals to 2, right? And then for our next value, we have 2 plus 1 over 2 factorial equals to 2.5. Do note that because our formula uses the previous value, because it's Euler plus 1 over 1i exclamation mark or factorial, we are then using 2.5 in the third pass. Apologies. And note that because our formula is 1 over I factorial, not 1 over Euler factorial, so we are using the I value for that. Just to be clear as well, we are writing 2.6667, sorry. But in your actual calculation, please use the exact value. Okay? And round only in the final answer. 2.70833 is what I got. It's not as hard as it seems, right? It's as hard as it seems? It's worse than it seems? I hope not. Okay. Any questions before we move on? Okay. Let's move on to... I'm going to come back to this, because I think you can read this in your own time. A lot of it's just general understanding. I'm going to get you to flick your page to page 16 for me, and you're going to have to turn your head or the page. I'm assuming we're brighter, so we're going to turn the page rather than our heads, but we'll keep with that. Page 16, thank you. I want to look at example 5, sorry. I'm going to go through solving this. You do not need to write this down because the answer is already on there, obviously. This is from Cambridge's textbook, and I'll give you some additional questions after the fact as well. I've just pasted at the very end of the booklet. You don't have to worry about that, but please follow along while I do this. A very clear distinction I need you to know. Our while loop is different from a for loop. Delara, Alex. Our while loop is different from our for loop. Our for loop is saying that, okay, I want this to be looping for 4 times or 20 times, right? Our while loop happens when the number of iterations required to perform a task is unknown. I don't know how many times I want this to happen. Okay, so the general template for this will be the same. We still start with our start. We do move into our condition. That should be a diamond, apologies. So for example, if, etc., and then we follow this true instructions, and then that should be an arrow there, apologies, and we go false and end. That is the same as we have done before. Okay, but again, take note, this is specifically when we do not know how many iterations we want. Whereas for our for loop, we want a specific number of iterations. Are there any questions about that distinction? Okay. Again, something to take note of that we're not worrying about right now is before when we had a for I blah 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 blah, and we would write end for. In this case, it's a while loop, so we write while, etc., and then end while. End while is an end the while loop. Apologies. I'm going to go through an example of writing it. I'm not really stressed about this right now. Again, we will have time for this. But it says write an algorithm that divides 72 by 14 and returns the quotient and remainder. To write the algorithm, what I'm going to do is keep it very basic, okay? I'm going to go ahead and go, and I'm literally copying this from, copying this from the Cambridge solution. So again, you don't need to write this down. So I'm going to define my count as 0 and my remainder as 72. So if I'm dividing by a number that, well, in this case, by no 14s, I'm going to have a remainder of 72. And then while, and you don't need to write this in a different color, but I'm doing this to make it clear, while the remainder is greater than or equal to 14, again, we don't know how many iterations we want, right? That's the idea of the formula. Then we define our count as the previous count plus 1, and our remainder as our previous remainder minus 14. So for example, if I divide by, if I remove 14, then I remove 14 by my remainder. If I remove by 2, for example, my count is 2 now, I've removed 2 14s, and I would reduce my remainder by 2 14s. And then I would write end while, and print, that should be on the left, print count and remainder, which just means, all right, once I'm done, I will print the count with the value of the count and print the value of the remainder. Okay, so in this case, the count variable keeps track of how many times your divisor 14 goes into the dividend. Your remainder is the variable that keeps track of what remains to be divided. So I'm going to draw a flowchart for this. Can I get you to copy that part down? Because I don't think, is that in the book? That is not. So I get you to copy this down. Thank you very much. Start. We're going to start with our count equaling to 0. Can you read that, Jetty? It's quite small. Okay. And then the remainder, I'm going to define as 72. I'm going to zoom in. I'm going to do my if. And I'm going to slant it to the side because I'm running out of space. If remainder is greater than or equal to 14. Oh, geez. That'll do. If true, then we go count. I'm going to go ahead and separate this here. The count is the next count, plus 1, just like we wrote earlier. And then we go remainder as the remainder, or the previous remainder, subtract 14. Oh geez, this is not the best. Apologies, we're going to have to make do. And then we go back to this. Are there any questions about what I've written? I know it's quite hideous. Yeah?
You know when you write the boolean true or false, does it always have to be capitalized?
Great question. It doesn't matter. Great question. And then I'm going to go ahead and do false and print the count and remainder. Given that this is an output, we should be using our rhombus as well. And of course, finally, to end it, we use end. Yes? Can we put both the count and the remainder in the same box? It's a great question. I don't see an issue with it. I don't see an issue with it. Thank you for asking. Okay. What I'd like you to do is on the, find some space either in your book or the bottom of the booklet. I'd like you to do a desk check for this. Okay, I know the answer's already there, but try to avoid just reading that right now and try to write out a desk check. The variables you need, of course, is your count and your remainder. Those are the ones we've defined. Give it a shot. This is the way that I've set out my desk check. So we have our count as a remainder. Remember that we always include the variables that we've introduced in the algorithm in our desk check. Okay, so we have a count and then a remainder. I've just gone ahead and written 14 plus, etc. If you just wrote the values of 17 and then minus 14, blah, 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 all the way down, that's fine as well. Okay, had a couple of questions about what an exam question would look like for this kind of thing. I cannot give you definitive answers. Of course, I haven't lived through this set of design more than you have, but of course, Vika has the exam questions that they've provided. We will go through them over the next couple of lessons, of course, so you will be familiar with what Vika has provided. A lot of the things that the other textbook companies have provided is more of an estimation of what's going to be on the exam. Okay, my prediction is that it's going to be exam 2 multiple choice. For example, what is the output going to be? That's what Vika has provided to us so far. Or it's going to be, for example, what's the error, or find what line 3 or 4 means, right? That's the extent of what the pseudocode question is going to be, in my opinion. So either a very short exam 1 question or a multiple choice in exam 2. Any questions?